speed is very slow. What is the problem? I'm unable to see them. Network issue. यार some network issue is there. I'm unable to see their response. Just 1 minute. What is the problem? Yeah. Yes. Good evening, everyone. Good evening, everyone. No. And now I got better. I got. Actually, for me, your some problem was there. System was not on. It was showing unresponse. No, I got it. Keshav, good evening. How many are there? Come on, quickly give me good evening so that I can come to know how many are there. Now only I started getting comments. Quickly say how many are there. Good evening, everyone. Okay, Keshav, Evan, Keshav, Shrutika, Jeeva, Keshav, Sharmila. Good evening, beta. Good evening, everyone. Good evening. Sorry for the delay. I slept here. I was so tired, I slept. Now look here. Last class we were talking about Rutherford model of atom, beta. We were discussing. Vishal, good evening. Keshav, good evening. Now I am there. How was your examination? How was your examination? Come on, quickly tell me. How was your examination? How was your examination? Was it good? Okay. Monday, what examination you are having? Monday, what examination? When maths and science is there, just send me. Nice, na? Now look here. Hi, Gitika. Gitika, I think it's Darshini. Time was not sufficient. Easy, na? Super. So now look here. Shall we start the work for today? Last class we were discussing about Rutherford model of atom. Okay. Interesting social. Okay. Monday it's social. Fine. Oh, he is Avinash. Okay, Geetika is Avinash. Okay, fine, I got it. Now let's start. Let's start the class. Last class we were discussing about it's already delay of 5 minutes. We have started this session. Now look here, beta. We are going to just first understand about atoms. We understood by J.J. Thomson that how many number of positive charges are there, that many number of negative charges are there, that many number of negative charges are there, and atoms are electrically neutral. So now, after that, Rutherford has done an experiment just to support the J.J. Thomson model of atom. What he did in this experiment is he took a gold foil, approximated how many atoms were there in that gold foil. Come on, start answering my question. Approximated how many gold foils were there in that atom? How many gold foils were there? Sorry, how many atoms were there in that gold foil? How many gold foils were there in that atom? How many? 1000 atoms. Absolutely correct. 1000 atoms. So we understood that. Okay, he took one particle. Can you tell me? Alpha rays were emitted by what? Alpha rays were emitted by what? Alpha rays were emitted by what? 1000 atoms, absolutely correct. Alpha rays were emitted by what? Alpha rays were emitted by what? Alpha rays were emitted by what? Can you tell me the answer for this? Alpha rays were emitted by helium. Super. Alpha rays are positively charged or negatively charged? Come on, come on, come on, come on, you can answer it. Helium, doubly charged helium atoms. Absolutely correct, Vishal. Super. Aishwarya, helium. Absolutely correct. Super. So now, heliums are positive or negative? This, they are positive or negative? Positive or negative? Absolute, Shruti. It's exactly positively charged. What had happened? We studied some part of the observation. In that observation part, we came to know that Rutherford was expecting something else, but expectation went beyond, and we saw that most of the rays got undeflected, and very few of them bounced back. Very few of them bounced back. Very few of them bounced back. What was the observation? Let's go back to the observation. So what was Rutherford expectation and what he exactly got? What was Rutherford expectation and what he exactly got? Rutherford expectation was the alpha particle to pass through the gold foil and produce bright scintillation at point E. So he thought that all the alpha particle will exactly pass, and he will exactly the alpha particle will make a bright scintillation at point A. It will make a bright scintillation at point A. Okay, but what happened? However, to his surprise, some of the scintillations were produced in region B and C. So here his surprise was, okay, somewhere outside also in that circular zinc sulfide screen, some scintillation he saw. So it's exactly, that means the rays are striking back. Means the rays after exactly striking, after striking the metal gold foil, after that it is bouncing and somewhere it is exactly coming back. So that that was exactly for his surprise. Now after that, these observations can be explained only if we assume that positive charges in the atom is concentrated in a very small place. So that means this observation can only be possible when the positive charge can be concentrated in a very small region. Then his conclusion exactly changed, and then in his conclusion, the ray which went very close to the nucleus got deflected back. Shruti, you are winning my heart. Super beta. This is exactly the perfect point, that the one which went very the nucleus, 1 or 2 was there which exactly retraced its path. Retraced means the path with which it went, and then same path it has returned. So that was exactly that was exactly the most important point. Same scattered, and for some surprise, absolutely correct, Ashwin. Very good, Ashwin. Super beta. God bless you. Auntie, do scintillation means rays? Yes beta, scintillation means production of a particular light of reflection there. Okay, a type of a light sensation produced there. So this scintillation were exactly there, because light is also a type of what you call ray only. Now when we take the light as a straight line, when light travel will be a straight line, that time we are taking that as a ray only. So that scintillation was produced, and for his surprise, he saw that not only in one place, that the expected place was A, but not at expected place A, B and C were the other places where the scintillation was produced, So now Rutherford expectation something else, reality met was something else. So following are the observations of Rutherford experiment, most of the alpha particle passed through the gold foil straight without undergoing any change in the direction. So the atom, many of the light rays went straight away without showing any deflection. Next important, a small fraction of alpha particle deflected, and out of 12,000, 1 out of 12,000 rebounded. Very good. Now from the above observation, what was the conclusion? Because the 3 are the observation right now. What we have seen in the experiment, that 3 are the exactly observation. Now from this observation, let's draw some conclusion. So the first part of the conclusion, we can draw that if most of the rays are exactly passing undeflected, that means atomic structure is mostly vacant. Atomic structure is having many empty spaces. Atomic structure is exactly having what? More empty spaces are there, and the nucleus is exactly, and the positive region is very much concentrated, means focused to a very small portion. Focused to a very small portion. That was exactly the point. That means since most of the alpha particle pass through the gold foil state without undergoing any change in their direction, this shows that there must be enough space within the atom. This is what I said. This is what I said, that there must be enough space within the atom. Because of that only it went, undeflected. It went undeflected. Okay, I hope you might have understood this point. It went undeflected. Now we are going to go to the next point. Go to the next point. Since alpha particles are positively charged, there could be deflection only in the positive charge body. Yes, because we already know that positive repel each other. Positive, they are exactly doing what? They are repelling each other. So if positive and positive is repelling each other, then our expectation was more repulsion will be there. But repulsive, exactly the rays which were rebounded, that were very exactly less. Okay, so that told one thing to us, that okay fine, the positive charge are not totally distributed in the structure of atom. It is concentrated into a very small region. Okay, so this was the another important point finding. I am fine Sikha, तुमको क्लास में मिस किया मैंने, कहा थी. So it is exactly concentrated into a very small region. Fine. Now the alpha particles which reflected through large angle passed close to the positively body. Yes, that is another important point. So the one which went very close, they only got deflected like this. Okay, the one which went and strike the atom structure, they only got rebound. Okay, they only got rebound. It is present in a small volume. Yes, the concentration of the nucleus is exactly very small. But it's exactly concentrated. The positive charge of the atom is concentrated in the nucleus, and the nucleus is exactly concentrated into a very small region. Okay, it is not the entire structure of the atom. You can see the positive. Only at the center you can expect the positive charge. Only at the center you can expect the positive charge. Okay, fine. So shall we go back to the next point, please? So the alpha particle which deflected through large angle passed close to the positive body. Now since alpha particles are very heavy positively charged particle, these particles could be deflected back only when they strike heavier body inside the atom. That is what we discussed right now, na? Ki alpha particles are heavily charged. So now heavy. So that means nucleus might be very heavy. See, Rutherford expected that if J.J. Thomson concept is correct, then alpha particles are very heavy charged positive atoms, and thin gold foil will have positive charges but in a scattered way, plus the positive charge will not be effective to exactly allow the light rays to strike back. Okay, so here you have to understand that, but for his surprise, the rays were striking back. That means the structure of the atom, the positive charges were not concentrated in entire structure. It was only concentrated into a small region, but the region where it was concentrated, or the region where the positive charges were present, that was a region of high positive charge. That was a reason of high positive charge. You have to remember this point. What was the concept of experiment? What was the conclusion drawn? There was a big difference in that. Okay, now why the big difference is there? I want my children to understand this point. If positive charges are distributed and it is discrete, it is exactly distributed nicely, and some gaps are there in between the region, then next important point will happen. A very heavily positive charge, when they will strike, then these scattered positive charge won't be able to create that much impact to let them bounce. Okay, so they will allow. So that's why Rutherford expected that all the rays will. This was the expectation, that according to J.J. Thomson, all the positive charge are very nicely distributed, and if a very high source of positive charge will go, then these distributed positive charge won't do anything, and this high source of positive charge will pass. And this high source of positive charge will pass. This high source of positive charge will pass without showing any deflection. But this was the expectation. The reality happened different. The reality happened different, and the reality happened is a very strong beam of positive charge went, but it got exactly started deflected. So it was all not concentrated at A. Rather than concentrating at A, it bounced back in B, C, D, E position. That is exactly proving. Okay, is it buffering? For me it is not buffering, beta. Is it buffering? Ashwin, now okay? Okay. Starting for me also slight problem was there. I faced internet issue. I was unable to see your chats. So I was waiting. What happened suddenly? There is a total blank. Nothing is there. I got scared. What happened? Now understood na beta. So we understood expectation was the rays were strongly come out of the thin gold foils. But in reality, the rays were, some of the rays were only coming out. Physics is also there, beta. Some of the rays came out, but some, okay Shika, is it okay now? Some of the rays came out and some exactly started making certain angle, and some started making certain angle. That was a very important point. So that was expectation and reality, both were different. Okay, expectation was something else, reality was something else. So now we will go to the next point. Since alpha particles are very heavy particle, charged particles, these particle could be deflected back only when they strike heavier body inside the atom. Only when they strike the heavy body. That means the structure of the atom is such so that the nucleus will be very heavily charged, positively charged. Then only a very heavy positive charge, when they will strike, then only it will have the capability to bounce it back. Okay, if it will not be highly positive charge, if the atomic structure or the nucleus will not be that much highly positive charge, then this heavy positive charge will go and cross it. Okay, but here it is not crossing, it is exactly passing and making certain angles if it is going very near to the nucleus. I hope you might have understood. Understood this part, beta. Kanishka, is it okay now, beta? I hope it might be now. Is it clear for you? Now is it clear for you? Shika, you asked notes, beta. Just I'll Instagram you added. Okay, Kanishka, I too had network issue today. I slept also, so that's why timing got so fully collapsed. Understood, Sharmila? Now, beta, understand the next important point. So now Shika, you joined Instagram, there I will send you the content, beta. So now look here. So since alpha particles are very heavily, these particles could be deflected by only heavy particles. So since very few alpha particles are rebounded, this shows that heavy body present in atom must be occupying a very small volume. So that is what Ashwin has also said. So that's the correct point only. Very small volume of the nucleus is there. Because of that, only few rays got strike back. Only Okay, only few rays got strike back, only few rays got strike back. Fine. So now I am going to give you the next important point. In the word of Rutherford, this result was almost incredible. If you were fire a 15-inch shell at a piece of tissue paper and it could come back and hits you, so 100% this was that case only. So exactly in the words of Rutherford, this statement was an awesome statement. What he said that this result was almost incredible. If you fire a 15-inch shell at a piece of tissue paper and come back and hits you, so definitely it was not expected, because we were expecting it will pass, but the miraculous content happened that the rays were bouncing back. Some of the rays were bouncing back. Okay, Telegram are you using? Telegram you are using, beta? So the rays were exactly bouncing back. That was an incredible experiment. So Rutherford alpha particle scattering experiment gives evidence for the existence of nucleus. This experiment also gives some important information about nucleus. So definitely now we had a concept that atoms are electrically neutral and number of positive charge equal to number of negative charge. But the structure of atom was somewhere different. But now Rutherford has proposed some very evidential points. The evidential points, the points which you cannot be able to cut. The first important point, what he said, that the nucleus of an atom is positively charged. Definitely it will be positive charge now, because we have seen that most of the heavily charged alpha particle, they went very near. See, most of them crossed undeflected, but the one which went very near only strike back. The one which went very near only strike back. So that was an evidential point. Next is nucleus of an atom is very dense and hard. Correct only. If it will be dense and hard, then only it will do another important point. If it will be dense and hard, then only it will do another important point. That important point is it will bounce back the rays, positively charged rays. It will bounce back the positively charged rays. Then only it will do this point. Now nucleus of an atom is very small as compared to the atom. That was another conclusion. Why? Because most of the rays, without striking and making some angle, they crossed undeflected. So I hope you might have understood three important points. What first important point is, nucleus is very, very small and very, very dense. Nucleus is very, very small and very, very dense. This was the first observation. Second is, it is exactly positively charged. Third, nucleus outer region is almost empty. So atomic structure is big, but compared to structure of atom, the nucleus is very, very small. The nucleus is very, very small. Okay, I'm moving for a minute. Just now tell the answer. I moved for a minute, just check. Okay, beta. So now a very important, interesting fact, I am going to keep it in front of you. I think all of you are watching cricket, huh? So now the comparison, what has been written there, you will definitely like the comparison. The comparison is like, if you imagine that an atom is very, very magnified, and we try to get this, we will try to get the shape of the nucleus and the location of the nucleus. So finding the location of the nucleus and about the nucleus is just like a cricket stadium. So one one stadium is there, and when you are exactly going to check in that stadium, at the center of the stadium, like a small pea is kept. Like that only they have compared. Like atomic structure is very, very big. Atomic structure is very, very big, and at the center a very like small pea, means think about peas. Peas are very, very small. Now think how much will be the big stadium is. That much stadium big and one small pea. So it is exactly telling one thing to you, that we cannot expect the, see, that is exactly one point of view I am telling right now. That is exactly one point of view is there about a ball in a stadium. You can explain like that also. A ball in a stadium also you can take. At the center a ball in the stadium, that can also be the explanation of stadium versus ball or nucleus versus atom. Stadium versus ball or what you called nucleus versus atom. So nucleus, atom versus nucleus means nucleus is very, very big, and at the center the nucleus is the atom is very, very big. At the center a very small nucleus is there. What happened to me? I am saying all the statement ulta today. So proton and neutron are called nucleons. Remember this point. Proton and neutron together are called as nucleons. Remember this point, कि when I say nucleus, we are telling the name na, but when proton and neutron together are taken, it is exactly, yes, proton and neutron together it is taken, then it is exactly called as nucleons. What it is called as? Proton and neutron together is called as nucleons. Repeat with me, nucleons. So nucleons, Nucleons, nucleons. So that is the particle which constitute the nucleus. So nucleons are the particles which constitute the nucleus. Nucleons are the particles which constitute the nucleus, means nucleons are present in the nucleus. That means nucleons means proton plus neutron is present in the nucleus. So just that is what beta, nucleons. Nucleons means proton plus neutron. Proton plus neutron together is called as nucleons. Fine. So now Rutherford put his theory in 1911. So his theory was proposed in which year? 1911. At time only electron and proton were discovered. Neutron were discovered in 1932. See how many years later? Almost, if you will subtract the year, it will come 21 years later. So Rutherford has given the concept of nucleus in 1911, and neutron was exactly discovered by James Chadwick in 1932. So almost after 21 years beta, 21 years, almost after how many years? 21 years we got what we got the concept of neutron, that inside nucleus not only proton is there, neutrons are also present. Inside nucleus not only protons are there, neutrons are also there. So this discovery was later added to the structure proposed by Rutherford, and after that only whatever discovery Rutherford has done, in that this concept of neutron has been added. I hope you might have understood. Come on, quickly give me a nod that you have understood the point. You have understood the point. Quickly give me a yes that you have understood. Can you see this? Can you see this? This is exactly hydrogen atom, and this is the size of the nucleus. This is the stadium, and this is the size of the P. So this is exactly this much big stadium is there, and 0.7 centimeter is the size of the P. So you think about all this, what you call that red dot, what is exactly showing. So green dot is electron. Electron means outermost orbit electron present, and red dot is exactly, red color is telling you that what is the size of the structure atom. Think what a small size of structure atom is there. Sorry, what small size of structure of nucleus is there? What happened me today? Structure of nucleus is there today. I'm just going to speak slow now. Now we are going to go towards the next important point, Rutherford nuclear model of an atom. In that, now we are going to understand the final conclusions. Now first conclusion is volume occupied by an atom mostly consists of lots of empty spaces. So now can you see the lots of empty space? And in this lots of empty space, electrons will be exactly present in the orbits. Okay, electrons will be present in the orbits. Yeah, even I can't see the red dot. From here also beta, red dot is very, very small. Red dot is very, very small. Now can you see the red dot? The red dot is very, very small beta. So now we have understood that the volume occupied by an atom mostly consists of a lot of empty space. lot of empty space is there in the atom. What is there? Lot of empty space is there in the atom. It is supported by the fact that most of the alpha particle pass through gold foil without deflection. So which observation of Rutherford has proved the first point? What is the first point? The first point is volume occupied by the atom. Volume occupied by the atom mostly consists of lots of empty space. Lots of empty space. How we come to know that an atom in the atomic structure lots of empty space is there? Then you will say, auntie, by the conclusion that most of the rays passed undeflected. Without doing any deflection, most of the rays passed undeflected. So that is what? It is supported by the fact that most of the alpha particle pass through gold foil without deflection. So first point about empty space, atomic structure is having an empty spaces, that was that was approved by the Rutherford experiment. That is, most of the rays, alpha particle rays, went undeflected. Okay, if it will be empty space, then only it went undeflected. So that is the connective point. Now next is, within the atom is located nucleus containing proton and neutron. It is because only a few alpha particles get deflected when they approach the nucleus. Correct only na? The nucleus will be the positively charged particles are present only in the nucleus. The positively charged particles were present where? The positively charged particles were only present in the nucleus. This theory was exactly backed by what statement of Rutherford? That is exactly, the Rutherford experiment says that only few of the rays got deflected back. And this theory is only supporting the statement that the theory that Rutherford has given, that only, or the experiment what Rutherford has given, that only says that only few of them bounced back. Only few, very few of them bounced back. Okay, and some of them deflected by making certain angles. So that is exactly proving the point that the nucleus is small and it is exactly concentrated and it is positive. Nucleus is small, concentrated, center, at the center, and it is exactly rebounding, means like this going. Rebounding means rebouncing, bounding. It is like this, beta. Going to one path and returning back to the same path. Going to one path and returning back to the same path is called as rebounding. So the size of nucleus must be very small. So now this fact was exactly told by the Rutherford also. Rutherford said about the size of the atom. He said that because most of the alpha particle pass through the gold foil and the radius of the atom were between 10 to the power minus 10 to 10 to the power minus 15 meter. So exactly the radius, nanometer it should be. The radius of atom is 10 to the power minus 10. So expected radius of atom he has given as 10 to the power minus 10, which is exactly bigger. Yes, only few came back. Now next point is, the electron revolve around the nucleus in a circular orbit inside the atom and at a very high speed. This circular path of electron are called orbits. So definitely Rutherford has talked about orbit. The most important thing is Rutherford was the one who talked about orbit. But Pavam, I am just using the word Pavam for Rutherford, he could have got that recognition and he could have got the most important the point. But only one structured drawing proved everything wrong for Rutherford. Rutherford said everything cut to cut correct. Here, when Rutherford is telling that the electrons are revolving in particular orbit, his concept is exactly for old concept, it was exactly new. Means it was exactly true. So old concept, it is exactly true means ki for that time the concept, because now we have quantum mechanics, and quantum mechanics have a different theory about structure of atom. They have exactly different theory about structure of atom. So we cannot in higher higher classes, you will come to know that Hund's rule are there, certain rules are there. So by that you will come to know that the maximum probability of finding electron is near to the nucleus, okay, and you will be finding the electron cloud will be more near the nucleus. So that part you are going to understand when you will go in higher classes. But Rutherford said one very important point that we are considering to teach the students, that is the atoms are revolving, the atoms are revolving, the atoms are exactly, the atoms have electrons which are revolving around the nucleus. The atoms have electrons which are revolving around the nucleus. The atoms are having what? The atoms are having electrons which are revolving around the nucleus. This was the theory proposed by it, okay. So that means the electrons are negatively charged which is revolving around the nucleus in a fixed circular path. But this is not the structure drawn by Rutherford. This is not the structure drawn by Rutherford. Rutherford gave the concept that electrons will be circulating in the outermost orbit. In fixed orbit, electrons will be circulating. But that the structure I have drawn, that structure was not given by Rutherford. So his structural defect was there. His structural defect means the defect of the structure of atom what Rutherford has given, that defect was there. But the concept of Rutherford was back to back absolutely correct. In his concept, we understood some points. Some of the points are, that is the electrons are revolving in circular path, okay, and the electrons are revolving at a very high speed, and then they have exactly energy. The electrons are having energy, and according to, yes, that was a Bohr model beta. According to Rutherford, it is having exactly an energy. Electrons are having energy, and they are exactly revolving around the nucleus. Okay. Now atoms are electrically neutral. This was the J.J. Thomson experiment. Also, we said that atoms are electrically neutral. What is the meaning of electrical neutrality? The meaning of electrical neutrality is number of positive charge equal to number of negative charge. Meaning of electrical neutrality, number of positive charge equal to number of negative charge. Okay, now electrostatic attraction between positive and negative charge as a whole was also there. So now we are going to go, the atom is electrically neutral, it has no neutron in its structure, the electron revolve around the nucleus. That was the concept, and now we are going to go back to a very important point. And that important point which got because of that Rutherford got criticism. Criticism means it was a very massive failure, because everything back to back what he said is still followed, because we have learned the concepts of Rutherford, okay. So exactly the concept was correct. Whatever concept was correct, it was whatever concept was there, the concepts were back to back correct, okay. But problem was only in one thing, and that is presentation of the structure of atom. See, when now one simple concept I am going to give it to you. Let's see how you are going to take the concept. Now you and your friend are there, you both are there. Now just take it as a simple concept. Every day you are getting 100 rupees pocket money, and your friend is getting 120 rupees as pocket money. Then every day you both are spending that money in whichever way you want. Okay, so now every time when you see your friend having pocket money of 120 rupees, you will be thinking about that why you are not getting 120 rupees. So you will go back to your father and say that daddy, exactly my friend is getting 120 rupees, can you increase my pocket money? Like that request you can make to your father. So in the same way, when we talk about energy, so money is what? Money is a type of energy. In the same way, the electrons, so the father, first we are going to go to the concept of understanding for that. So now, concept of understanding for that, then the father will be exactly explaining that no, my situation is not like that, I cannot give you 20 extra rupees, okay, because every day I have to give you 20 extra rupees, I cannot afford to give you 20 extra rupees every day. That means there is a difference in energy level, Okay, because friend is slightly rich, so he is getting 120 rupees. He is not that much rich, so he is getting only 100 rupees. In the same way, when we talk about structure of atom, then the orbits do have energy level. Okay, and according to the energy level, the electrons are exactly present inside it. According to the energy level, the electrons are present inside it. And another important point is कि when these electrons are revolving, they are releasing energy. Okay, so they have energy, they are going to release energy. So when they will release energy, see, absorption of energy is a certain different thing. So if I am in second orbit, so I deserve to be in second orbit, and I am releasing energy in second orbit, no problem will be there. But according to the structure, if something will release energy, then what will happen? It will exactly becoming smaller and smaller. So if someone is having 2 crores of rupees, you will say that person is rich. Now if I'm going to snatch that 2 crores of rupees from that person, then that person will not be called as rich, the person will become poor. So now he will go to a different lifestyle. First he had a different lifestyle, and then he is having a different lifestyle. So what are the reason behind giving these examples? The reason behind giving these examples are exactly you have to understand change in energy level. Change in energy level. So each orbit is having an energy level, and we always move from lower energy level to higher energy level. We always move from lower energy level to higher energy level. So right now my energy level is only to get 100 rupees pocket money. Now my friend energy level is to get 120 rupees pocket money. So that means I am very much happy in my world. I am releasing this energy. Every time I am getting this energy and I am releasing this energy in my own orbit. Now my friend is one status above me, so energy level increases from lower orbit to upper orbit. This is what is my first point to tell you. Okay, so lower energy increases from lower orbit to, so energy increases from lower orbit to upper orbit. Now that is one other important point. And each orbit is having a specific energy level. Each orbit is having a specific energy level. An electron revolves in that specific energy level, and electrons are revolving in that specific energy level. So that is the another important point. So we came to know about कि when electron will be revolving, it will release energy. So but if circular orbit is there, so in that circular orbit it will release energy, no problem. Let it revolve and release energy. Now what happened when the structure will be like this, then what will happen? That means the electron will keep on releasing energy. The more electron will release energy, the more its orbit will become small. See, if orbit is fixed, then electron will be revolving in that orbit only. But if the orbit is exactly spiral in structure, then every time electron will be revolving. Yes beta, every shell of an atom is having different energy level, lower energy level to higher energy level. K shell is exactly having low energy level, L shell energy level is higher than K shell energy level, M shell energy level is exactly higher than L shell energy level. So when we will go for lower energy level to higher energy level, I repeat, when we go for lower energy level to higher energy level, the energy level increases. Okay, from first orbit to third orbit energy level will increase. Okay Shikha, now look here beta. So that means we have come to know about everything, but problem is the spiral structure. So when Rutherford explained the spiral structure, what will happen in the spiral structure? The electron will keep on rotating in a spiral orbit, and one moment will come, electron will keep on releasing its energy, and one moment will come, electron will fall into the nucleus. And once the electron will fall into the nucleus, the structure will collapse. And once the electron will fall into the nucleus, the structure will collapse. So because of this, I am just giving you the final conclusion that atom do not, Rutherford gave an atomic model of atom, does not explain the stability of atom. Correct only na? How stability of atom will be explained when the structure will be like this. Okay. So now you understand this. In Rutherford atomic model of atom, the negatively charged electrons are revolving around the positively charged nucleus. Correct? Negative charge revolves around positive charge. This is also a new concept also. But It has been found that electrically charged particle revolving around in a circular path then always radiate some energy. Thus, in an electron, if an electron move around the nucleus, it must continuously radiate an energy and is gradually move towards the nucleus in a spiral path till it collide into the nucleus. So this is one, it will keep on releasing, it will keep on rotating because energy is there in electron, specific energy is there in the electron, so it will keep on rotating, and the more it will rotate, better it will go, because electron will start its journey and it will exactly keep on rotating, and one phase will come when it will fall into the nucleus. So structure won't exist for that case. So however, we know that atom is very stable. Rutherford model could not explain its stability. So here the stability is at stake. So if somebody will be Vishal, I am reading, I am going to read your comment out, just 1 minute. Where is your comment? Vishal, resend your comment. I lost your comment. Resend your comment. I lost your comment here. Resend your comment, Vishal. Resend your comment. Fine. So I hope you might have understood this point. So now we are going to go back. So we know that atom is very stable. Rutherford model could not explain because the electron, they are releasing energy. I told you electron will release energy. So if electron will release energy, one time will come, it will fall into the nucleus, because it will, the more it will release energy, the more its energy level will be reduced and it will go near to the orbit, near to the nucleus, and one stage will come, it will fall in the nucleus and the structure will collapse. Vishal, you have to send the question, because I told I lost the question. I told you now I lost the question. Now Shika is telling, ma'am, the energy of an atom A and B of cell K, then they, ma'am, the energy of atom A and B of cell K, then their energy of electrons are same. Okay, understood. What you are wanting to say that yes, they will be belonging to same energy level, then only they will be in that orbit. If there will be difference in energy level, electron will jump to that orbit where the energy level of the electrons and the orbit will be same. Where the energy level of the electrons and orbit will be same. Okay, energy level of the electron and orbit will be same. Now we are going to go to the next part, that is called as Bohr model of atom. Now the structural mistake was exactly rectified by Bohr. The structural concept and mistake was rectified by Niels Bohr. So Niels Bohr in 1913, Niels Bohr, which you sent before, I didn't got this. In my WhatsApp you have sent that you are asking, or now you have sent that you are asking? Okay, so in 1913, Niels Bohr, a young Danish physicist, suggested that electron revolve around the nucleus and confine to a certain certain fixed orbit and envelop the nucleus much the same way as the skin of an onion. So he is exactly enveloping the nucleus much as like that of onion. So layer by layer you can see. Okay, and then he said that electrons do not lose any energy while revolving around the nucleus. So when after this he just stabilized, see, if spiral structure will be there, in that structure electron is having a specific, I told you na ki you and your friend, you are exactly having different energy level. You are getting a pocket money of 100 rupees, your friend is getting a pocket money of 120 rupees. So if you and your friend both are having different pocket money, that means you both are in different orbits, you both are in different energy shells, and you both are not going to match up with each other. I hope you are enjoying today's class. I hope you are liking today's class. That is, they both are enjoying. They both are exactly enjoying different shells. So one shell lower energy cell, another shell higher energy cell. So if the electron will want, electron cannot jump to this place, electron cannot go back to this place. Okay, so the particular orbit electron, okay, WhatsApp, that I will answer. The particular orbit electron will be in that particular orbit, and when they will be revolving in that orbit, that time, since they have a specific energy level, they will not be releasing energy. They will not be releasing energy. They will be having energy, but they are not going to release the energy the way in the spiral structure it has been shown. The way it has in the spiral structure it has been shown. Okay, so now next important point is the nucleus confined. The electron do not lose any energy while revolving around the nucleus. At the time of revolution, it is not going to release any energy. Next is, he further suggested that electrons cannot move in the area between two orbits. Correct only. Now another important point is that the electrons are present in specific orbit. The electrons are present in specific orbit. Like orbit number 1, electron is present. Orbit number 2, electron is present. But the number of electrons present in different orbit, they must have exactly some gaps in between, and the electrons are not jumping in that gap. So the thing here is, that is what it suggested, the electron cannot move in areas between two orbit. So between these two orbit, you cannot see electron dancing here. Okay, between two orbits you cannot see electron dancing here. Monday, what exam you all are having? First you have to tell me, beta. Monday, what exam you all are having? Monday, what exam? Accordingly, I will give you holiday for preparation. Fine. So now in next class we are going to talk about the k element shell. We are going to talk about the position of electrons. Next class only we are going to discuss about Bohr model of atom in much details. If you want study leave, in another place, but I am keeping the offline classes. Okay, don't worry. Shika, just give me some contact number or where I can give you send the PDF for you. Okay, I'll send the PDF for you, beta. So I'm going to keep it till here. Good night, everyone. Tomorrow evening I'll keep the class. Okay, or send me the timing, which time you want the class, so that I can finish this chapter. Tomorrow most probably I'm going to finish this chapter. Yes, Shika, you can contact me in my number.